Welcome to DBS Talks. Now in this class we are discussing the subject is utilization of electrical energy. Okay, so in this class we are discussing our 4th unit numerical problems on a traction. Okay, so that means you have to see the problems and analysis of simplified speed time curves. That is those and trapezoidal speed time curves and quadrilateral speed time curves. Okay, so you have to see the first problem. An electrical weight 250 ton has 8 motors. Okay, so a train having the weight of 250 tons has 8 motors. Okay, 8 motors geared to driving wheels. Okay, geared to driving wheels. Each is 85 centimeters diameter. Okay, so and each motor is 85 centimeters diameter. The tractive resistance is of 50 per ton. Okay, so and here the tractive resistance is 50 per ton. The effect of rotational inertia. Okay, and the rotational inertia is 8% of the train weight. The gear ratio is 4:1. Okay. And the gearing efficiency is 85%. Okay, and efficiency is 85%. Determine the torque developed by each motor to accelerate the train to a speed of 50 km per hour in 30 seconds up a gradient of 1 in 200. Okay, so now, so in the problem, okay, so what is the problem will be given? Okay, so here the electric train of 250 ton has 8 motors. Okay, and it having 8 motors geared to driving wheels, having each motor having 85 centimeter diameters. Okay, and the tractive resistance is 50 per ton. Okay, the effect of rotational inertia is 85%, gear ratio is 4. Okay, so and the gear efficiency is 85%. So here you have to find out the torque developed by each motor. Okay, so what is the torque developed by each motor to accelerate the train to a speed of 50 km per hour in 30 seconds. Okay, so that means in 30 seconds, okay, to accelerate the train speed of 50 km per second in a gradient 1 in 200. Okay, so that means here you have to find out the torque. Okay, torque developed by the each motor. Okay, so that is the value you have to find out in this problem. Okay, first here you have to note down the given data. So here the weight of the train W equal to 250 tons. Okay, so weight of the train W equal to 250 tons and the diameter of the driving wheel D equal to 0.85 meters. Okay, so diameter value will be 0.85 meters. Okay, so here in the problem it will be given as 85 centimeters. You have to convert that into the meters. You have to divide with 100. So at the time here the diameter of the driving wheel will become 0.85 meters and the tractive resistance. Okay, so the tractive resistance R value will be 50 Newton per ton. Gearing efficiency. Okay, so gearing efficiency is 85%. So at the time eta equal to 0.8. Okay, so accelerating weight of the train. So accelerating weight means, so here you have to get the accelerating weight. Okay, you have to multiplying with total weight of the train into 1.10. So at that time whenever you have to multiply with 1.1 into 250. So at that time this is the formula. Okay, so this is the formula to get the accelerating weight of the train. Okay, so to get the accelerating of the weight of the train, here you have to multiply total weight of the train, dead weight of the train into 1.10. Okay, so at that time here you can get W equal to 1.10 into W. Okay, that means that is equal to 1.10 into 250. Okay, so at that time here you have to get the 275 tons. Okay, so acceleration alpha equal to Vm. So maximum speed will be given in the problem is 50 km per hour. Alpha acceleration alpha equal to Vm by T1. So Vm means 50, T1 means 30. Here you have to get 30 seconds. T value will be 30. So at that time here you have to write down 50 by 30. So at that time here you have to get the acceleration will be 1.66 km per hour. Okay, so here you have to get the acceleration value will be 1.66 km per hour. Okay, so now tractive effort, Ft value. So what is the formula to find out the tractive effort? Ft equal to 277.8 We alpha plus 98.1 Wg okay, plus Wr. So 277.8 We value will be given as, you can get the We value will be the 275. Okay, so and alpha value will be, here you can get 1.66 kilometer per hour. So plus 98 point into W 250 G 200. Okay, G value will be 200. Okay, 1 year. So in G value will be given as 1 in 200. So at that time here you have to get 200 plus W 250 into resistance 50 Newton per ton. So whenever you have to substitute all these values in this equation and you have to simplify, at that time here you can get the tractive effect. Ft value is 1,51,578.2 newtons. Okay, so this is the tractive effect value here you can get. So finally, but here you want which value? The total torque developed. Okay, so here the total torque developed T equal to Ft into D divided by eta into 2 gamma. Here gamma means gear ratio. Okay, so Ft value here you can get the 1,51,000. So that means why you can get this formula means from the mechanics of train movement. We have to discuss it in theory topics. Okay, from the a formula of mechanics of train movements. What is the formula for the Ft tractive effort? Ft equal to 2 eta gamma divided by D. Okay, so from that from that torque developed T equal to Ft into D divided by eta into 2 gamma. So the tractive effort Ft value will be 1,51,578.2 into diameter 0.85 divided by efficiency. Efficiency will be also given as 85%. So at that time here we have to write 0.85 into 2 into here gamma value will be 4. So at that time here we have to write 18.947.25 Newton meters. Okay, so this is the total torque developed. Okay, so 18.947.25 Newton meters. Okay, so this is the torque value. So this is the total torque developed by the 8 motors. Okay, so here the train having 8 motors. So at the time to find out the torque developed by each motor. Okay, to find out the torque developed by each motor. So at the time here the total torque developed by the value is divided with the 8. So whenever you have to divide it with this value with 8, so at that time here you can get 2368.409 Newton meters. Okay, so this is the torque developed by the each motor. See here, next one is a tram car. A tram car is equipped with 2 motors. Okay, a tram car is equipped with 2 motors that are operating in parallel. Okay, so 2 motors are operating in parallel. The resistance in parallel. Here the resistance value in also parallel. The resistance of each motor is 0.5 ohms. Okay, and here the resistance of each motor is given as 0.5 ohms. Calculate the current drawn from the supply mains at 450 volts. Okay, so now here we have to find out the current. Okay, current drawn from the supply mains at 450 volts when the car is running at a steady state speed of 45 kilometers per hour. So that means, and here the car will be operating at the speed of Vm 45 kilometers per hour, and each motor is developing a tractive effect. Okay, so and here each motor developing a tractive effect of 600 newtons. The friction, windage and other losses may be assumed as 3000 watts per motor. Okay, so now here the friction, windage and other losses are power. Okay, 3000 watts per motor. So see here the resistance of each motor is 0.5 ohms and voltage across each motor V will be 450 volts. Tractive effort. So in the problem, these are the values, all the values in the given problem. Tractive effort Ft equal to 1600 newtons and maximum speed Vm equal to 45 kilometers per hour. Losses per motor, that is equal to 3000 watts. Okay, so at the time the power output from each motor P equal to Ft into Vm by 3600. So at the time the total power output from each motor will be given by 2000 watts. So why you can get how you can get the 20,000 watt means FT value will be 1600 newtons, VM value will be 45. So that is you have to convert it into kilometers into meters. So at the time here you have to write 45 into 10 cube divided by 3600. Here per hour will be converted into the per second. So at the time total value you can get the 20,000 watts. So copper losses. What is the formula for copper losses? I square into Rm. Okay, so this will be printed will be mistake. It is not I2 Rm. This is I square Rm. I square into Rm value. Resistance of each motor will be given as 0.5. Okay, so at that time here you have to write what is the formula for input, motor output plus losses. So here coming to the, so what are the losses, constant losses and copper losses. Okay, so in motor, so you have the, in motor always two losses will be present. Those are constant losses and copper losses. Okay, so already you have to study in mission subject. So at that time motor input equal to motor output plus constant loss plus copper loss. Okay, so at that time what is the motor input VI? So what is the voltage VI? That is equal to motor output. You can get the 20,000. See here, you can get the motor output value will be 20,000 watts, 20,000 plus constant losses. In the problem will be given as, in the problem 3,000 watts, 3,000 plus copper losses 0.5 I square. So at that time this equation will become 0.5 I square minus 450 I plus 23,000 equal to 0. This will be become a quadratic equation. Okay, so whenever you have to solving this equation, so at that time here you can get the I value 54.39 amperes and the total current drawn from the supply mains. Okay, so at that time 2 into 54.39. So at that time finally you can get the 108.778 amperes. Okay, so this is the current drawn by the each motor. Okay, so that means here two motors. So at the time the current drawn by the two motors, at the time here you can get 2 into 54. This is only each one motor 54.39 amperes. Whenever you want the total, but in the problem we are asking the current drawn by the two motors. So at that time you have to multiplying this for 54.39 into 2. So at that time this will become 108.78 amperes. Next we have to see the another problem. Here see locomotive. Locomotive is nothing but train. Locomotive exerts a tractive effort of 35,000 newtons. Okay, so here the locomotive exerts a tractive effort of 35,000 newtons in a halting a train at 50 km per hour on the level track. Okay, and here the speed of the motor will be given by 50 km per hour. If the motor is to halt the same train on a gradient 1 in 15, and here the gradient value will be given as 1 in 15, and the tractive effort required is 55,000 newtons, determine. So first, okay, first tractive effort, locomotive has tractive effort of 35,000 newtons having a train speed of 50 km per hour. So whenever and the tractive effort is 55,000 newtons, determine the power delivered by the locomotive if it is driven by the DC series motor. Okay, so now you have to find out the power value if it is driven by DC motors, or if it second one is if it is driven by the induction motors. So first here you have to write tractive effort. Ft equal to 35,000 newtons, maximum speed V equal to 50 km per hour. So at the time power output will be given as Ft into Vm by 3600. So Ft value 35,000, V value 50, so kilometers. So whenever you have to convert into meters into 10 cube divided by 3600. So at that time here you can get the 4,86,111.11 watts. So at that time here you can get 486.11 kilowatts. Okay, so this is the power output. Okay, so at the time the power delivered by the locomotive upon gradient track with DC series motors. Okay, so at the time here you can write, so this 486.11 into square root of 55,000 by 35,000. Okay, so whenever it is DC series motor, so at the time the tractive effort will be given by 55,000. So at the time here you can get 609.37 kilowatts. If suppose the power output delivered by the locomotive upon the drive with an induction motor. So here why you can write this square root of power means see here this is the power, so into square root but here power output is directly proportional to the ft, but here it is directly proportional to square root of ft. Okay, so that's why 486.11 55,000 divided by 35,000. Okay, so at that time here you can get the value will be 763.8875 watts. Okay, so this is the power output delivered to the locomotive whenever the motor will be a induction motor. Okay, so this is the solution of this problem. Okay, so next we have to see the another problem. So here a train weight 450 ton has speed reduced by the regenerative braking from 50 to 30 kilometers per hour. Okay, and here the speed value will be reduced by the regenerative braking. Okay, from the 50 kilometers per hour to 30 kilometers per hour over a distance of 2 kilometers. Okay, so at a distance, so whenever the train will be starts, whenever it a 450 weight train will starts traveling, so whenever it starts from its destination to 2 kilometers, so at that time the speed value will be reduced to 30 kilometers per hour. Okay, on a down gradient of 1.5%. Okay, so and here gradient value will be 1.5%. Calculate the electrical energy and average. Okay, power returned to the line reactive resistance is 50 Newton per ton. Okay, so which value here you have to find out, calculate the electrical energy. Okay, and here calculate the electrical energy and the average power returned to the line track resistance is 50 Newton and allow the rotational inertia of 10% and the efficiency conversion is 80%. Okay, so now here you have to find out the rotational inertia of 10% and efficiency conversion is 80%. Okay, so here you have to write. So always the accelerating weight of the train is 1.1 into 450. Okay, so at that time here you can get 495 tons. Okay, the distance traveled is d equal to 2 kilometers. Okay, and the gradient is 1.5%, and here the track resistance is 50 Newton per ton and efficiency eta equal to 0.8. Okay, so that means here in the problem here given 80%. Okay, so that's why here you have to write 0.8. The energy available due to the reduction in the speed is, okay, so in according to the speed time curves. Okay, so trapezoidal speed time curve, here you have to write the 0.0. So here in the problem, so it will be not given that is which speed time curve. So at that time you may assume that is either trapezoidal speed time curve or either quadrilateral speed time curve. Here you have to assume the trapezoidal speed time curve. So at that time is given by 0.01072 W V1 square minus V2 square. So of V1 square minus V2 square. So V1 50 square minus 30 square, W value will be 495 and 0.1072. So at the time here you can get, whenever you have to solving this one, whenever you have to multiplying this total term. Okay, so at the time here you can get the value is 8490.24 watt hours. So whenever you have to convert this into the kilowatt per hour, so at the time here you can get the value will be 8.49 kilowatt hours. Okay, so the tractive effort required while going down the gradient. So whenever you have to take the gradient, so at that time the value will be, so here that means only during the acceleration here you have to take. So whenever you have to take the gradient, so at the time here you have to write ft equal to wr minus 98.1.wg. W value will be 450, R value will be 50 minus 98.1 into W means weight of the train. Okay, weight of the train in the problem will be given as 450. And here gradient G value will be 1.5. So at that time here you can get minus 43,717.5 newtons. Okay, so whenever you have to solve this equation, so at that time here you can get the value will be 43,717.5 newtons. The energy available while moving down the gradient on a distance of 2 kilometers. Okay, so whenever it will be down the gradient at a distance of 2 kilometers. So at that time, the energy available is given by Ft into D into 1000 by 1000 into 3600. So that means here you have to convert into the kilowatts. Okay, so that's why you have to multiply with 1000. Okay. Ft value 43,717.5 into D value T into 1000 by 1000 into 3600. So at the time here you can get 24.2875 kilowatt hours. Okay. At the time the total energy available. Okay. So the total energy available is 8.49. So what is the 8.49 value? 8.49 is the energy available due to reduction in the speed. Okay, so this is on the gradient value. So at the time the total energy, okay, so at the time you can get the total energy available value. So at the time you can sum of these two values, okay, due to the reduction due to the gradient. 8.49 plus 24.2875. So at the time here you can get the value will be 32.77775 kilowatt hours. Okay. So here the average speed will be, average speed is nothing but 50 plus 30 by 2. So at the time, that means first the speed of the train will be 50. After that, the speed train will be reduced to the 30 kilo. So that's why here you can write that is equal to 40 kilometer per hour. Okay, so 50 plus 30 by 2, 80 by 2. So at the time it will become 40 kilometer per hour. The time taken to recover 2 kilometers. At the time you can write 2 by 40. That is equal to 1 by 20 hours. Okay, so the average power. What is the average power? The energy returned to the line divided by time. Okay, what is the energy returned to the line? 26.22 divided by 1 by 20. So at the time, whenever you have to solving this one, so at the time here you can get 524.44 kilowatts. Okay, so this is the average power. Okay, next we have to see the another problem. So here an electric train has an average speed of 50 km per hour on a level track between two stops 1500 meters apart. So whenever you have to take the electrical train, so it is having a speed of 50 km per hour. Okay, on a level track between two stops. Okay, so in between two stops, okay, the distance will be 1500 meters. So it is accelerated at 2 km per hour and is braked at 3 km per hour. So and here the acceleration coefficient is, acceleration will be 50 km, alpha will be 2 km per hour and beta c is 3 km per hour. Estimate the energy consumption at the axle of the train per ton per kilometer. Okay, so now here you have to estimate. Okay, estimate the energy consumption at the axle of the train per ton per kilometer. Take the reactive resistance constant at 50 Newton per ton and allow 10% for the rotational inertia. So here see acceleration. Acceleration alpha equal to 2 km per hour and retardation beta equal to 3 km per hour. And here the distance of run. Okay, distance will be given by the 1.5 kilometers. Okay. 1500 meters means whenever you have to convert this 1500 meters into the kilometers, so at that time it will be given by 1.5 kilometers speed. Okay, speed VA equal to 50 kilometer per hour. Okay, so the time of the run T equal to D by VA into 3000. To convert it into the seconds, here you have to write 1.5 by 50 into 3600. So at that time it will be becomes 108 into 10 to the cube seconds. So here by using the quadrilateral speed time curve, here you have to write Vm equal to T by 2x minus square root of T square by 4x square minus 3600 by x. But here x equal to 1 by 2 alpha plus 1 by 2 beta. That means at that time you have to write 1 by 2 into 2, alpha value will be 2, beta value will be 3. So at that time you can get 0.416 Okay, so now you have to substitute in this formula. T will be 108. T will be 108 milliseconds divided by 2 into 0.16. Okay, so minus 1.108 whole square by 4 into 0.416 minus 3600 into divided by 0.416. Okay, so there will be no 3.5. Okay, it is pre-take mission. Okay, so at that time whenever you have to solving this equation, at that time you can get the Vm value will be 67.603 kilometer per hour. Okay, so at that time you have to take the accelerating period. Accelerating period d1 equal to Vm by alpha. So at that time Vm 67.603 by alpha value will be given as in the problem 2. So at that time whenever you have to solve it, so at that time you can get the accelerating period T1 equal to 33.8015 seconds. Similarly, braking period T3 equal to Vm by beta. So at the time here you can get 67.603 by 3. So at the time you have to solve, at the time here you have to get 22.534 seconds. So the distance traveled, okay, the distance traveled during the braking. Okay, so at the time here you can write half Vm T3. Okay, to convert into the seconds, here T3 you can write it 3600. T3 by T, so Vm value will be 67.603 into 22.534 by 3600. Whenever you have to solve in this equation, here you can get 0.2115 kilometers. Okay, this is the distance traveled braking. Okay, so whenever you have to distance traveled during the acceleration, so at the time total distance minus distance traveled during braking. So at the time this is 1.5 distance, the total distance value will be given as 1.5. So at that time 1.5 minus the distance traveled during braking period will be given by 0.21115. So at that time the distance traveled will be given by 1.288 kilometers. And here the reactive resistance will be given as 50 Newton per ton. So and what is the ratio of accelerating weight by total weight? 1.1. Okay. So from that one, the energy consumption at the axle of the train per weight of the train will be given, 10 kilometer will be given by. So what is the formula? 0.01072 Vm square by D into W by W plus 0.2778 or D1 by D. Okay, so at that time here you can get the W by W value is 1.1, Vm value will be 67.603. Okay, and here 0.01072 divided by 1.5 into 1.5 plus 0.278, R value will be 50, D1 value will be 1.228, D value will be 1.5. Whenever we have to solving this one, here you can get 35.927, and whenever you have to solve this one, so at that time here you can get 11.926. So whenever by adding these two, 35.927 plus 11.926, so at that time here you can get the 47.853 watt hours. Okay, so this is the energy consumption at the axle of the train per ton kilometer. Okay, so whenever the problems will be asking, so either we have it is find out either time period, okay, or speed, okay, or power. So sometimes it may be given as the directly in the problem will be given as assuming trapezoidal speed time curve or assuming quadrilateral speed time curve. So whenever in the problem will be given as a trapezoidal speed time curve, so at that time you can assume the equations. Okay, so we have to see the in the analysis of simplified speed time curves, that is in trapezoidal speed time curves and quadrilateral speed time curves. We have to see the uh, equations. Okay, equations for the trapezoidal speed time curve as well as for the quadrilateral speed time curve. Okay, what are the equations we have to get for the trapezoidal speed time curve? We have to substitute the given values in that equations. If suppose in the problem it may be asked the quadrilateral speed time curve, at that time you have to take the quadrilateral speed time curve formula equations. At that time you have to find out the solution. If suppose it will be not mentioned either that is trapezoidal speed time curve or quadrilateral speed time curve, So at that time, that is your wish. You can may assume seat refrigerator speed time curve or coordinator speed time curve according to the given data. Okay, so these are the some of the problems on the electrical traction too. Okay, thank you.